Welcome back everyone, we have a massive new install update for you. Until now we've had AGM batteries running our system. We didn't have problems with the batteries themselves, we had problems charging the batteries. But we overcome that eventually, and now we have problems with the batteries aren't providing enough voltage to the fridge constantly, so our freezer isn't as cold as we want it to be. And also we now want to run our solar, because we're in a warm environment, we want to run our solar or in the afternoons when it gets hot without being connected to the grid or having shore power. Hey babe. Okay, so we would like to have that option. Who wouldn't? Because it does get hot in here, doesn't it, sweetie? Yeah. And even if you stop for lunch at the side of the road, you want to run your solar, and you really want a lithium setup for that. We have tried running the alternator into the batteries and getting good sunlight for it, which had worked, but it really drains the batteries very quickly. Yeah. Okay, so we've decided to have a lithium battery setup, haven't we, babe? Yeah. Yeah. And this is, we have it. These are our lithium batteries. Look how big that is. We're going to have 2 of those. Okay. So we've also got ourselves a couple of 200 watt folding solar panels that we can whip out whenever we want to supplement it when we're running our air conditioning. And so we can show you what we intend to install, we can show you why we're going to install it, and we can show you how we're going to set up our new battery system to protect it. And we can show you our embarrassing existing setup. Hey babe. Yeah. So these are the things that are going to go with those new batteries. They're 240 amp hour Solarking, and once we get them running we can give you some feedback on how they are for us. Now to run solar batteries, you can't just use your existing chargers. You need preferably a solar lithium specific sort of battery chargers. So there's 3 different types of chargers that you have with your batteries. You've got your DC to DC charger, you've got your solar charge controller, and you've also got your 240 volt charger as well. Okay, so all of those three things have to be compatible with lithium so that you can maximize the batteries. The power. Yeah, because lithium's a little bit higher voltage and there's a lot more that goes into it, so it needs a bit more protection. Okay, but they are actually cheaper to run in the long run because they get more cycles than your AGM, and they're also much better for use because the voltages don't come down as much as the AGM, especially when you're consuming power. Hey babe. So this is what we've got. This is the charger we run from the 240 volts. We've mostly got this is a Victron Energy. This is a Phoenix Smart IP43 charger. So this charges your lithium batteries, and it can also send a small trickle charge to your battery in the front as well, which is really handy. Hey. Okay, so there's that. We've also got 2 DC to DC chargers. This is also Victron Energy. We'll show you pictures of these, but this is DC to DC chargers. Our alternator is at least 140 amps, and these run 30 amps into your, can run up to 30 amps in your batteries. So if we've got 140 amps in our alternator, then we can run a couple of these into our batteries. We've also got a Smart Battery Protect, which allows you to set a voltage to cut out your consumers so that you're not using too much of your battery, which just extends the life of your battery. So there's this here, and you can also wire a switch into this, which will cut out your consumers, so that if you want to leave your van or something for a while without being used, you can just switch this off and all your consumers will stop draining your batteries, which is really handy. Hey babe? Yeah. And the other thing is the battery monitor. We already have a battery monitor, but this is much more lithium compatible because it allows us to do, it allows us to do two things. It allows us to monitor the temperature of the batteries, and you'll see why monitoring temperature of the batteries is important. And it also allows you to cut out your charger, your solar charger, via Bluetooth, so that you won't charge your batteries when the temperatures of the batteries is below 0 degrees. And it also has a line in it that we can run to cut out the other charges into the batteries as well, whether it be DC to DC charger or whether it be your 240 volt charger that we have. We can run a switch into those so it stops charging the batteries when the temperature's too low. So really good battery monitor. But priorities, we've got to get our priorities right. We've got to get these two batteries in. Then we've got to charge the batteries so that they're ready to use, and then at the same time we need to switch over the solar array into the new batteries. At the same time we change over the consumers, so Susan can use the consumers while I'm away, and then if I've got time I can do all that other stuff and get it. But eventually you'll see the whole install and everything, what comes together, how it comes together, and what we did to program it. We won't mess around too much with showing you wiring and stuff, but you will see how it's all fused in for us, and how it all works for it, and eventually we'll give you a bit of feedback on our new system. All right, so follow along, and we'll be able to show you our new install. Hey babe? Okay, now this is our existing setup. If you want to come down here, sweetie, these are our existing batteries. These are our Full River 105 amp hours. There's 3 of them. 1, 2, and the other one's back here. 3. Those are our 12 volt batteries. They're just AGM. Okay. So that's what we're replacing out with our lithium batteries. So the lithium batteries will replace those. These 3 things here, that's going to stay where it is. We used to have different 240 volt chargers, and this is the new one that I've already installed, but we have to reconnect that to the new batteries. Reconnect that to the new batteries. Now this is going to stay where it is. This is just the inverter. All we need to do is change this over to the new batteries. And these are our consumers, and that's a fuse panel for all of our consumers. Now if you come over here, what we have here, this is the DC to DC chargers. This comes from your battery in your front, from your alternator, and into the DC to DC charger. These are not lithium compatible, so they're coming out, and we're replacing those with the other 2 Victron Energies that we have. This we probably don't need, so we're going to take this out as well. This we were using for any large power drains that we'd have over short periods of time. So we were using that. We're probably going to take that out, but I would like to keep it if we have space. We'll see how we go. So all that stuff we've shown you before, hopefully we can fit it here, but if not, we'll just have to figure out how it's going to go in. So the new batteries are going to go here. The new batteries are going to go 1 here and 1 here, but we'll also have the option of putting a 3rd one in case we want that. So we'll see how 2 goes, 1 here and 1 here, and then we'll put in the rest of it and we'll see how it goes. Hey babe.
Okay.
All right. Okay, so we've done most of the installs now, and this is our battery install for the lithium batteries. Since we originally did the videos on the batteries, we had 2 lithium batteries that we were testing out. We didn't know if we wanted a 3rd one. We decided to go with a 3rd one. We have Solarking 240 amp hour lithium batteries. So with 3 of them, we're making up a bank of 720 amp hours of lithium batteries, which is quite a lot, but that's what we wanted. We wanted to be able to run our air conditioning off the solar batteries. Now with our previous setup, it was quite a mess, and we originally, when we had the van, we only had one battery, one AGM battery, and so we added another battery. We had other equipment that we wanted that we added. We added a 3rd battery as well to the system, and it slowly, we got more equipment, more consumers, and it slowly just became a complete mess. I'll show you shortly in the video where previously it was just a complete mess. There was wires everywhere. It wasn't how we had wanted it, but it just slowly became a mess. So what we've done here now is that we've wired it so that we won't have the wires crossing over each other where they aren't fused, and where they do come together, everything is fused. So what we have here now, and show the wiring, sweetie. What we have here now is the main terminal comes off, has a class T fuse, a 300 amp fuse, and that protects the inverter. Okay, and from that we have a bus bar which connects to that fuse, and from that distributes out to all the other consumers and the other chargers as well. So that's all protected as well with this stuff, and it's much more tidier than before. It's not perfect, but the cables are all hidden behind here now, and it's definitely much better. Okay, the next thing we're going to show you is the solar charge controllers. This one we've had for a while. We've got mostly Victron Energy stuff, but this one we've had for a while. This runs the solar on the roof. So from the solar on the roof comes down into this and then into our battery bank. The other solar charge controller that we have is for the supplementary solar. So the supplementary solar, we've got a room to expand here. We've got 650 watts going into this, but we can run up to 70 amps. So we've got room to move. We could pretty much double that, maybe even more, and utilize some more if we have a cloudy day, but that runs up to 70 amps. This smaller one here is only 30 amps, and we've rarely ever seen it get up to 30 amps. So theoretically speaking, we could be pushing in 100 amps of power from the sun only. Okay, we've just got these little U-tacks on it to stop the little lights from keeping us awake at night time. But other than that, it's pretty simple wiring, photovoltaics in, and then battery out. So next we have the 240 volt charger. So it takes 240 volts AC from shore power and charges into the batteries at the charging algorithm that it does. Anywhere between 12 and 14.8 volts. But that pushes into our battery bank. It also has a charge cable going into the front battery as well, and that connects to this here, this cable here, which is also runs to our battery at the front. So that comes from here, and that's our Victron Energy 240 volt charger. So we've got 50 amps pushing into the batteries from this at the back, and only 3 amps going into the battery at the front. Okay. Next is the inverter. This is probably one of the few things that aren't Victron Energy. This is a 2000 watt inverter. This is able to run our air conditioning no problem. The air conditioning consumes anywhere, we find, between 600 and 900 watts of power for the aircon. It depends on how long it's been running for, how cool it is, how warm the cables are. But 2000 watt inverter, we really only need about 1000 watts, and I don't think I've ever seen it go above 1200 watts with the things that we consume. The other things we can consume, obviously the fridge, but the Susan's blow dryer, and also the other blender. The blender, that's right. Yeah, so that's what this would run, but mainly we have it running the air. Now the main thing about this inverter we found was, because we started using the aircon through this from the batteries for longer periods of time, we found that the cable that we had wasn't enough, because we were getting so much voltage drop between this and, which is the Smart Battery Protect. Can you see that in the camera? So so what we decided to do, we got bigger cables. So we changed out, we originally had 2 6-gauge cables running on it. We changed that out to 1 0-gauge, and now instead of having between 0.5 and 0.6 of a volt drop between the batteries and this, we've now only got 0.2 to about 0.3 voltage drop, which we find is acceptable. Okay, so this is running much better now, and we're pretty happy with that. So next we have the Smart Battery Protect, and what this does is this prevents over discharge of the batteries. This has already saved us a couple of times, but because the lithium batteries are so expensive, you don't want to be over discharging them. So what this does is this tells it to stop consuming to protect the batteries. We've got it set to cut out at about 12 volts. We're yet to install, there's a little alarm that you can install as well. So it's just basically a little buzzer we've purchased. So that will tell us just before it would cut out, maybe about a minute or so before it cuts out. But that way you've got a little bit of warning to turn off your air conditioner, otherwise you won't be able to use your lights for the rest of the night. So there's the alarm that we're yet to install. We also noticed that when the aircon is running, this can heat up a lot, and especially we noticed it when we didn't have the fans installed. But what we've done to address that is we've installed just little washers between the Smart Battery Protect and the back board to provide a little bit of space or gap between itself and the board, so that air can flow in it to increase the surface area of this, because it's already got a heat sink in it. So that's cooled it down quite a lot. We've also added the fans. So the fans now, they're cooling the Smart Battery Protect, they're cooling the DC to DC chargers, they're cooling the inverter, they're cooling, even when we have shore power, it's cooling this. So it's keeping it much cooler underneath these new fans that we've had, about 8 degrees cooler we found by running our tests. We've got 2 injection fans which are much quieter, long-lasting fans, and if we really need it, if it's super hot, we can run the extraction fan as well to keep things really cool, but we have to put up with the noise. But we only run that if we need to. Okay, we try and keep it you know, at least in the 30s at least. So ideally that's the sort of temperature we'd want to be running. This Smart Battery Protect provides power not just to the inverter, but also to another bus bar which goes into consumers. So if we want to run another fuse box and another set of consumers, we can run another one off this bus bar here. Okay, so what we have next is our DC to DC chargers. Okay, now these can run 30 amps in each into the batteries. So we're taking power from the alternator, from the front battery, into the DC to DC charger, and it's pushing into the batteries at the lithium charging algorithm. Now we have it wired, according to the manual, we have it wired B and D, which I'll show on your screen now. It's B is H-pin wiring, which is the positive, and that connects to the L of this here. Okay, now they both connect to each other because they're both wired into each other. and that goes into the L, which is from the ignition. So the ignition, when you turn on the ignition, it's telling these to turn on, which is what I want. I don't want this thinking it's got to operate when I'm not even running the alternator. So we've got that wired in, and we've also got another. So that's B. Now D is the remote on-off, which runs through the battery monitor. Now this comes through here, it's all positive wiring, and it comes through here, it runs up to the battery monitor, okay? And inside the battery monitor, it's got a little relay. So that can switch this off when certain parameters are met. Well, we'll get to that. But we've got 2 of these, each at 30 amps, and ideally we want to be running 60 amps from the alternator into the batteries. Our alternator is capable of anywhere between 140 to 150 amps, and these were asking for 60 amps. Okay, now it's all wired correctly, but we're experiencing too much voltage drop for the distance and the wire size. So we're planning on resolving that by reducing the distance, because at the moment we've got an extra 1 meter, 2 to 2.5 meters of extra wiring distance that we don't need to run, because originally the batteries were all the way at the back here. Now they're a little further. So we're going to reduce the distance. We're going to increase the wire size from 4 gauge to 4 naught, which is pretty much the biggest cable size that you can get. And we're also going to be installing 1 farad capacitor here to act as a reservoir, so that when the vehicle is idling, the reservoir can be consumed and continue charging the batteries. And when we're running the engine at say 2,000 to 3,000 revs, which is normal for our van, it can fill up the reservoir and continue charging through the DC to DC chargers at 60 amps all the time, which is what we want. We want to drive from one place to the other at full charging, and ideally if we're charging with both of these at 60 amps plus with the solar charge controller at 30 amps, if we're driving from one campsite to another, we'll be pushing in 90 amps, which is great, because we want to top these batteries up quite a lot, especially if we're running a hot environment and we're running the air conditioner. Now next we have, beside the batteries coming from the negative, going through the negative line, we have the shunt. It's a bit hard to see here, but this is the shunt, and that provides information to the battery monitor. Now we also have another cable connecting to the shunt, which is sold separately. This is for temperature monitoring, so we'll be able to monitor the temperature of the battery bank. So that goes into the shunt, and that information feeds into the battery monitor. So you're constantly monitoring your battery, especially if you're running so much power out of these batteries like we are with the air conditioning. So that's the shunt. So battery monitor. This battery monitor, it does quite a lot, but what we want it for is for monitoring whether the battery, the voltage is, if the voltage is too low, it will also set off an alarm. In addition to the Smart Battery Protect, which would also set an off alarm when we set that little buzzer in. But this monitors the voltage of the batteries themselves, whereas the Smart Battery Protect is reading the voltage at the Smart Battery Protect, which can be different between the Smart Battery Protect and the batteries. Slightly different, maybe 0.1 of a volt or something like that. But this can activate an alarm and tell you if the voltage is getting too low. We've got that set already. It also sets an alarm if the temperature is too high, and that will activate the relay. And we've got that set at 50 degrees. So when that activates, it will activate the high temperature relay and stop charging with the DC to DC chargers. All other devices, whether it be the solar charge controllers or the 240 volt charger, will start to reduce charging at 40 degrees, and it will slowly stop charging up to all the way up to 50 degrees. The DC to DC chargers do something similar as well, but by the time it gets to 50 degrees, it's not charging anything anyway. So high temperatures we're not too concerned about, as it's already built into the design to stop charging already. But what we're really looking to do is to make sure that it stops charging when the temperature is too low. And so what we've programmed it to do is to stop charging, detect the temperature, and when the temperature gets to 5 degrees, we want these devices to stop charging. So when we have programmed it to cut out with there's an internal relay which goes to the DC to DC chargers, okay? So what we talked about before with the DC to DC chargers, where the internal relay opens a little breaker, and it breaks that circuit so that the DC to DC chargers stop charging when the temperature is too low, because the lithium batteries don't like to be charged at low temperatures. You can consume the power, I think, but it doesn't do them any good to charge them at low temperatures, so you've got to wait till these temperatures come up. So it does that to the DC to DC chargers through that little cable and the relay, but it communicates the temperature to the solar charge controllers and the 240 volt charger via Bluetooth. There's a smart networking, Bluetooth smart networking that Victron Energy has, and it communicates this data to these devices, and from those devices you tell it not to charge when it gets to 5 degrees. So that's a handy little thing that we have. So we're very protected, whether it's high temperatures or low temperatures, we're staying within that range. And it's all automatic. We don't have to think about it, although we do want to monitor it so we can sort of plan around it. We've got that sort of protection and safety that we're staying within between 5 and 50 degrees. All right, so that's everything inside. We'll show you there's a handful of a few other things we want to show you outside that we've been doing as well. Because we're running the supplementary solar, we obviously don't want to have cables running through the van, doors or anything like that. So we've run those cables outside. We'll show you what we've done there, and Susan's very happy about the new antenna, aren't you, babe?
Yeah.
All right, so we'll come outside, we'll show you what we've done there, and we'll show you our new plans for the external lights, hey?
And the extra solar that we have.
Yeah. Come over here. So we originally had you might remember, we originally have the antenna on the front here, and that would come up about quite high. And yeah, whenever we go past trucks, it'd move around. It was quite annoying. It would block Susan's view. Yeah. And it didn't actually, after a while, it didn't work. so it was there for quite a long time, and it didn't do anything. So I've never had it on the top because it would make it too high. Yeah. So what we've done is we've installed like this little, it's a retractable sort of antenna. So we put this on this side here. I didn't want to put it on the back or anything. I didn't want it to be sticking out any further. I didn't want it to be coming forward, but I also didn't want to be getting the ladder out every time I wanted to put the antenna up. So yeah, I put it on this side because I can just step onto the seat here and access. Okay. There's a little, come on over this side and hold it up nice and high so they can see the little pivot that we have. And so all I need to do is stand on the front seat. I can press a little button and I can stow it away. Away the antenna when we're not using it. Yeah, when we're driving, we put like that, right? Yeah, I mean, we've got the option of putting it at a different angle or anything like that. I don't know if we'd ever want to do that, but when we get to our camp spot or anywhere we need good signal, we can put it up, and we're really noticing the difference now, aren't we?
Yeah, yeah.
So that's our new antenna setup, right?
Yeah, good, babe. I like it. What you did.
Antenna,
Okay?
yeah. What we had to do with that antenna and the supplementary solar, we needed to run cables through the van. So we had to make a whole new line through the van, and that was a bit of a challenge for us. But we managed to do it, and we've sealed it all up nice. And there was 6 gauge cables, plus the antenna cable, plus another few cables that I'll get to in a minute. But these cables goes to show the supplementary solar that we're running here at the moment. They've been running there for about a week, so they need a bit of a clean. But that's our supplementary solar, 650 watts worth, that we pretty much double our solar array going into the batteries with those. So those cables connect into these little wires. I'll get just with a little ladder, get up to those and connect those when we get to our camp spot. And we've also, the other cables we've got running through that little conduit there through the roof is we're planning on putting some light bars, some LED light bars across the top as well. So we haven't installed those, but that's the 3 things outside we're planning on doing. And on the other side, the same thing, we're going to be putting some light bars, so we're looking forward to that. Hey babe?
Yeah.
So that's our lithium battery setup, and we hope you really enjoy the install and how it all come together. And we can now run the air conditioning when it gets hot. It really takes the edge off. But what I'm thinking is we may want to get some more supplementary solar, but how we're going to do that yet, we're not sure. So stick around, subscribe, and I'm sure you'll like the future videos to come.